Hello guys and welcome to another video series. Disable that. Okay, anyways. So today we're doing traffic lights. Now, we do have to know that when we're doing this, it's hard a little bit, but I'm here to make it easy for you guys. I have a script that makes this 10 times easier to do with open computers. And you don't have to panic. Now, I'm not gonna show you redstone. Unfortunately, there is a way to do it with Project Red without having to install open computers or not if you have lower end computers. That's up to you to figure out. I'll give you a hint though, it uses a state cell and it uses a bunch of wires and it just loops. There's no way to have a flashing mode, there's no way to have solid red, there's no way to have a power failure with that one easily. Now you can, if you wish to have that. It will just take some more time and more space unless you know what to do with the Project Red stuff that allows you to do blueprints and make it into one little small thing. I've done it before, and I might have some more intersections that use that feature. However, it's still big long run because you have to have control boxes all over the place to control each individual frame cycle. This code allows more advanced stuff and stuff like that. So I just use a creative server for everything. Which turns on and connects to the back for the redstone part. So that's how you do that. Now we're going to go over the script. The links down below in the description will be the base code that I'm using that starts you off so that we can start where I left off. And we'll also leave the link to the mods that I'm using for this. So I'm using Open Computers, Project Red, and I'm using Traffic Control. I'm also using the RTC, which is the modified version of traffic control, which is what you're going to be seeing me program with. The modified version of traffic control is something I did to modify the game, the mod, just slightly to give me better looks and stuff like that, which is why we have all these blocks instead, including horizontal. But you can do this, the same thing I'm doing in this video, you can do in traffic control, vice versa, because they're both the same. It's like sign packs and stuff like that. I'm not going to get into much details on why my modified version is and what it is. However, we do have a simple setup here. So white just stands for the script's running. That's all it means. It means that the script has started. It hasn't lost power and been rebooted, which can happen from time to time. Which you can also tell with the blue lights off and stuff like that. The blue light here, cyan, is the light that turns on when this is on. That means the lights are in normal mode, not flashing mode. If it's off, it's in flashing mode, which is possible by flipping a lever as well, which is what the red means. The red means it's in manual flash. It means the script is running as normal. However, the computer is being told to do opposite of that. And that just simply tells it, hey, turn cyan off. Simple enough, right? Anyways, so we have now a fully completed open computer setup, and also here's the, I'm going to show you the cards that I have in there and the reason why I use servers. We have the graphics card, we have the redstone card, which is tier 2. It has to be tier 2 if you're doing Project Red for the redstone part, and a debug card, which allows me to run commands via the thing, which is useful for cloning traffic lights for certain scenarios. And we also use it for sensors if I use a sensor. I'm not going to show you that in today's video. However, if you want to see your lore, another mode is manual mode. That would be another video as well that I'll be doing. And in that video, I'll explain how to have a manual button. So you can do an override. So that way you can manually override the lights and control the faces manually, which is useful for like in real life to use them for events. That way, the police itself has control over the lights. That way, traffic is a lot better we manage. Because, especially in this scenario, where it's all automatic, it does it on its own. No sensors are in play. Since there's no sensors, you want a manual mode. Which I think is what they use in the life for. But yeah, manual mode is useful for that. And then we also have basically this is now. Here's the reason why you would want to do this in open computers versus automatic mode or redstone is customization. There's so much customization you can do. Like this diversion diamond is not possible in automatic mode because the directions are all in the same direction sometimes, especially with the angles of the lights. So it's actually you actually need open computers to do this. The other reason is if we come down to this intersection, which by the way is cable lights. If you ever want to do that, a little tip here, bonus tip, is that you can use a multiverse wire relay and the immersive engineering medium voltage relay and then the wire, and you can actually make it look like it's a hanging traffic light. Now it doesn't hang like it does in real life. It doesn't have that direct. You can set that up probably to make it look like it's hanging downwards a little bit because of the weight. But yeah, this looks like it has really high tension basically in this mode. But yeah, as you can see, it looks great actually compared to the ones on the poles. Also, if you're wondering how I did this for certain things, like this over here, because you need this if you want to look inside of a fence. This is coming in my modified version at some point. I didn't know that much, but I don't know when. But it's just chisel bits of block of aluminum, which matches the same color as the poles. So it's just chisel bits. So we get a block of aluminum from immersive engineering. You can actually chisel and bit it and make that. It's not hard. You gotta make sure everything lines up correctly. And then I just put a pool and then put the actual light down, so it's 2 blocks down. That would separate from the pool a little bit. Anyways, back to coding topic now. So what we're gonna need is either a tier 1 or a tier up to tier 3 card. You can also use a creative card if you're in creative. I believe you're gonna have 16 slots, so remember to keep that in mind. Unless using the modified version, you have 28. I'm not sure why I did that, but anyways, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Just enough for the tier 1 card if you're not using the modified version. Literally just enough. So you can actually do this with a tier 1 card. You always have to keep count because this intersection right here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So if you were to do this in traffic control, like regular traffic control, you would not be able to do it with the tier 1 card. I try to do a tier 1 card when I can. I always go up a level when needed though. Because obviously there's going to be some cases where a tier 1 card's not going to be able to support all your frames. Anyways, now for programming. Programming's real easy actually in this game. I like to do it by phases usually. That one's a little bit different. I did it by direction because it's a little bit more complicated. But however, I like to do it by phases. So I do my phases in phases. So whoever can be controlled is combined. So I'm doing northbound first because that's the priority of traffic. So northbound will go straight through here and continue to go straight through and go over straight. That way they don't have to be stopped as easily. And then that will also include this left turn here, since this left turn won't have any conflict point, and this right turn over here, since this right turn won't have any conflict point because this will be stopped. The other option too is to, I'm not sure how they do it in real life, but in real life I think they do straights while they do lefts. So like these straights will go and those straights will go while lefts are going, and then it'll flip to the rights, and then these will go and stop. And actually, that's a better idea. Actually, we'll go ahead and do that. So we'll start with the right-hand turns because that's actually, let's start with the left-hand turns. So that way the exits are cleared. Because when it's in this fast shape mode, they may not be able to get through right away because the traffic may not be listening to the reds on the main, even though they're supposed to. But anyways, so here we go. So we're gonna do the lefts first. The left phase is simple. We're gonna do the 2 lefts. So it's 1, 2, and 3, 4. This is actually easier phases to program as well. And this storm's caused me to lag. So it's storm. Oh, there we go. Killing some full storms. That's why I'm lagging. Okay, so we have that. I always have a train running around somewhere. I believe it's in. Yeah, it's near the. It's coming this way actually. But anyways, there we go. So we have that now. So we have 4. So we're gonna go to our code. We're gonna do local phase 1 left bulb equals to 1, 2, 3, and 4. And then we can come down here and do set lights. Phase 1 left bulb. Then we're gonna do green arrow left and return that on. Okay, now we need to do is a simple thing, and that is add these straights, because these straights will be on along with the lefts. So we need to do 5, 6, and 7 and 8. All right. So local phase 1 S for straight bulb. I'm just gonna do shorten because I don't feel like spelling it out. Let's be 5, 6, 7, and 8. So we have the first phase. Then we'll set lights. The trick is to do each bulb individually. I'm not sure if the script that I have supports multiple bulbs. I don't think it does. I'm just sure you could probably make it do that. But yeah, so we're gonna do green. No, straight. STR straight green. If that's wrong, we can always fix it then. So there's gonna be a testing phase. All right. Now we have our calculations. I like using my own calculations, so I already calculated it. So you have 32 seconds on the green. So we're gonna ahead and do os.sleep. And now it would be 32 seconds. Then what we can do is set lights to phase 1 left bulb and turn that yellow arrow left, and that will be on. And it automatically clears it unless you tell it not to clear. So we don't need to turn it off or anything. So phase straight bulb, we'll tell it to go straight yellow, and that will also be on. Sleep 3 seconds, because that's the time I calculated with the website. So it'll be 3 seconds yellow and 1.3 seconds red. Then I'm just gonna simply copy and paste this so that way I don't have to type it out constantly. So then all we do is change this to red and a red. And then os.sleep 1.3. Okay, that's it for that phase. Now it's easy from here. So actually, it's actually the same exact code for the phases, except this would be phase 2 left, right? Bulb. And now actually be shorter because the phase 2 straight bulbs will actually be the ones controlling that one right turn. Okay. Now we have to get the numbers correct for up here. That way we can define our bulbs. So we're going to do local phase right bulb and local phase straight bulb. So that's all we have to do now is get those paired. I like to pair these in order. So first I'm going to do the one right turn over here because this is 1 and 2. So it's going to be 9 and 10. Now we can't do the other right turn. Now Normally, it would be a right turn bulb in real life, yes. However, this right turn, even though it has the right on red up to stop, it just goes straight into the lane. So I decided to make it straight arrows instead because it makes more sense to the drivers. But yeah, you can still go straight on red after stop here in this area because it's considered a right turn still. Yeah, so now we're at 10, so this would be 11, 12, 13, 14, 15, 16. And there we go. We have all 16 slots filled. We do 11, 12, 13, 14, 15, and 16. So that's a lot. This code is done. So all we have to do now is put up this in. Now, the way I do my code, I don't have to paste in the code into the game. But if you had to, copy and paste. But I do something called live edits, and I have that on in the settings for open computers, so it makes my life 10 times easier. So what we're going to do now is turn this on, and we'll give it a go. And I'll set it. Then I'll show you how to do the flashing manual flash mode here. So we're going to kill the storm again. So we're going to wait. Right now it has power. The script is running. We have confirmed that the script is running. It hasn't started yet. It usually takes 60 seconds for this to start for me because that's how I have it set up to do. But yeah, while we're waiting for this, using this knowledge that you learned in this video, you can actually now set up a proper phase of traffic signals. It could be a hawk beacon, it can be whatever it's timed. Sensors and stuff, like I said, it'll be in a future video because I don't want this video to be too long. However, this is a general basics line, and it also shows you how to do a manual flash mode because that for some people is important because then you can do at nighttime it flashes. There we go. All of them are showing up as red. Except over here. So we have the left turn green. That goes straight. We got the straights wrong. We can fix that. Then we have the left turn here as well. And again, got the straights wrong. But we can fix that. Don't panic. That's what happens, by the way, if we don't do the right bulb. This is why you can't combine them, unfortunately. Because they are going to show blank. But the script will still work, even though they're showing blank now. It's just clearing them out. So I have to figure out the spelling for that. I probably misspelled straight. It's usually what happens. Also, she got the right arrows wrong. So now we have a bunch of blank bulbs. So we're going to go ahead and shut off this computer now because the bulbs are starting blank now. We're going to fix that. And now I'm also going to show you how to do the manual flash as well. That way you can manually flash it. First, let's fix the straight issue. So to fix that, I'm just going to, because I know I got the spelling correct. I just need to, on the green, I just need to fix that spelling. There we go. I'll leave a link, by the way, too, what the bulb names are so that we can properly program as well down in the description. Also, this needs to be right instead of left because we're not controlling the left bulb here. We're controlling the right bulbs. This phase. And boom. So that should fix the script. Oh yeah. Also, to do the manual flash, so what we're going to do is if get bundled output to colors that red is greater than or equal to 1. So if it has a greater than or equal to value of 1, then it will turn on. So it doesn't matter what power you set it to it. Then it will do that. We're going to end it constantly. Then you just copy and paste it for each little phase here. Now you want to end it after the seconds. That way it's not waiting the full cycle. That way when it's done, it can go back to normal. And actually the best way to do this is to separate the phases into this. So one phase, two phase. But because the way this works, we're going to do that. We're going to do that. Okay, there we go. So now we have that. Then we're going to tell it to do that. So you just do it after the seconds, and what's going to end up happening is because it is showing as on, it's never going to turn itself off. Now, you do need a way to tell it that, hey, I'm on. So up here is where you're going to do it. So then we're going to do, is set bundled output. Got cyan to colors dot cyan, and then we can set 0. Else, we're going to set the bundle output to cyan back on. So cyan dot colors dot cyan, and then that will set that to the 200, and then we'll wait 8 seconds. OS that's sleep. 8 seconds. Now we'll turn the lights back to normal mode. Okay, so now we can complete the flashing mode without even turning off the script. So we'll turn it on, we'll start the script. You see the script just started. Now, when it comes to manual flash mode, obviously Diversion Diamond probably wouldn't have this ability for that because it doesn't make sense, but it can. The way I have my by the way normally is it's not set up like this normally. Normally the priority streak gets yellow and then the non-priority streak gets red. However, due to the fact that this is a Diversion Diamond and there's so many cross points here, because you can't just have straights go through on the northbound and southbound at the same time. I'm not sure how they would do it in real life, but the flash mode is meant for like if the power is lost or whatever reason. So I just have it set to flash all red in this scenario. So we're gonna have it. We're gonna test the cycle up fully, and then I'm gonna set it to manual flash so that way you can see that. And then I'm just gonna keep it on that mode because this intersection isn't even open yet. Right now it's just testing. I mean, it's open semi-ly, only to certain directions. So you're going to see now that the left turns are going to go here in a few seconds. It's only 8 seconds here of waiting time, so unless it errors. If it errors out, then it has it. It may be halting because of the red, but I don't think it is. Yeah, it is. So that red sequence is what's causing it. That's how you do it, though. That still returns, right? Yeah, it returns a bundled input. That should be 0. Oh! If less than equals to 1. Less than equals to 0, sorry guys. You may want to change that for all of these. And the reason for the 0 is because you want it to be 0 if you want the script to run. And I just see why it's doing it, but it's not working on the else. So we'll do this. So we'll just end it immediately. And this one will be greater than or equal to 1. Let's see if that works. So we gotta turn off the computer and turn it back on. Traffic. This is why you test your code. Now, as you can see here, it does take a minute sometimes to fully get your intersection operating, which is why I'm doing this video first before any of the other complicated stuff. This is just the bare basics of getting a light working with the flashing mode on, of course, because that is actually important for lights, because you want to put a manually put it to flash, for example, like if you're just coding it real quick and you want to go back into flash mode while keeping the computer running, but you also have to just flip the lever and it goes into its modes. That's what it's used for. Mainly useful for right now, because like this intersection, it's not going to be actually be able to fully abuse traffic lights to traffic to do. People are just going to be sitting waiting for no traffic at all because it's closed. They can actually safely continue to go at the moment. This is just a test trial run. Like they would do an IRL, and then they'll set it back to flashing mode for a bit until it's officially ready for its actual use, the purpose of why it was installed. But yeah, this is the first time I ever actually really implemented it, so. Okay, so now we're just there we go. So now it's doing its normal cycle. Okay, that is interesting. Behavior. So the lights went into flashing mode because it turned off the lights. I wonder what happens if we were to set the yellow, but I think I know what's causing it. It's this right here. So we told it to turn off when it's less than 1. We actually need to flip these results. So if we flip the results here, it should start to function as it should. Maybe. Like I said, this is my first time actually truly doing it this way, because I haven't really done it before. I mean, I've done it once, but it was a different style of editing at the time, because at the time I couldn't just put it in the code. I didn't have the get bundled input the same way. So I wonder if this will make it work. Oh yeah. If you ever get into weird glitch phase, you can always just send a signal like that and it'll fix the lights. There's actually a reason why I have push buttons there. It just resets them. In case that it was ever to freeze, it's a good idea to have that, because there's gonna be instances where something like that happens, and like, how do I reset it? Because now there's half flashing, half not, or all on and weird. But now we're testing it once again, so we're waiting. This takes forever sometimes. I recommend sending this for a lot shorter distance if you can, but it will be 60 seconds when you get the base code. Okay, so once that blue light turns on, we should see it turn on. And hopefully we don't get that same weird glitch where the lights flash for some weird reason. Here in a few seconds here, it should turn on the cyan. There it goes. So now everything's turned red for 8 seconds. There it goes. Now everything's working as should. So we have our lefts, and that goes through. We'll wait a full second before we try out the red, just to make sure. And then we have the same thing over here. Make sure. Yes, we do have the same thing. Everything's going when it should so far. Now we just gotta see what happens. That way, make sure it's 100% working before we try that yellow flasher, because what that does puts the lights into flashing mode. It purposely sets them in without having the computer do the work. And we also need to make sure it goes back into normal mode as well. without any glitches. Alright, so the phase is complete. Now it's going to do the phase. Of all the right turns and stuff. Make sure it's all working. It is nice. So we have a full working fledged system. Now we're going to head and tell the computer to turn off after this phase is over and to go to flashing mode. So now this takes a minute. It has to finish this last cycle. There it goes. As soon as the last cycle is finished, it will turn to off the thing and turn it to flashing mode. And you will notice none of the things are actually working. It's going to continue to spam console if you have that text line. Just keep that in mind. And when it goes back off, everything goes back to normal. It'll wait 8 seconds and then the cycle will resume. Now, as you notice, that lag was from the text line. If you don't want that, what I was just doing is putting another if statement like this, except reversing the priority. Which is how we know that it's not that. I actually don't understand how this works, to be honest. But we want red to be less than. So if red is greater than, what we can do is set a 1 second timer. And then that will basically avoid the print as well. So then you can put this in the here. Now for this part, you may be wondering, can I make this without it affecting the other loops? Yes, you can. It's just best to keep it this way. Now, you want to do it too is if cyan's already on, for example, it doesn't do the slash check. So what we're gonna do is if cyan is greater or equal to 1, we're gonna end it. That'll prevent that from re-looping because cyan's already on. We don't want it to keep looping. I won't have to wait 8 seconds for the red cycle to finish. So we do that, and then we'll turn on the script, and I'm just gonna turn it on. And after it starts, I'm gonna turn it straight to flash mode, and it will be ready to go. Then you can also see that it down like our spams the chat. It also doesn't make you wait 8 long seconds. I think that's what's been happening. Is it will complete its steps, but then it has to wait an additional 8 seconds because the thread is off. We don't want that. We want it to wait 8 seconds if cyan was already off at the time. But cyan will be on by the time it hits that the first time, so we don't have to wait an extra additional 8 seconds. We're going to test that here in a moment. But yeah, anyways, I hope you guys enjoyed this tutorial video. If you have any questions, feel free to let me know down in the comments. And you can also join my Discord. And I can help you there. Anyways, I'll see you guys in the next video.